This call is now being recorded.
Okay, so in the last lecture, we have started with the third type of the beam, that is Sfd and Bmd for the cantilever beam. And based on that, we have solved one numerical in the previous lecture. And before that, we have discussed about the sign conventions used to draw the Sfd and Bmd for the cantilever beam. There is a one difference between Sfd and Bmd for the cantilever beam and the simply supported or the overhanging beam. So in case of a simply supported beam, whatever the SF calculation we are starting, that SF calculation we are starting from the left side of the beam. That means upward forces we are taking positive, downward forces we are taking negative, and same sign conventions we have considered for the simply supported as well as overhanging beam. But in case of a cantilever beam, whatever the BM calculation we are doing, that BM calculation we are starting from the right side of the beam, because if we do that calculation from the right side, your simplification or your calculation part becomes very simple. That's why only we are starting the BM calculation for the cantilever beam from the right side, and as we are starting from the right side, the sign convention will get changed. So in case of a bending moment calculation, if we are starting the BM calculation from the right side, your clockwise movement or the clockwise couples we are taking it as a negative, and if your couple or if your movement is anti-clockwise, that we have taken as a negative. And based on this particular sign conventions, in the previous lecture we have solved one problem for the cantilever beam. Now again today we will solve some more two problems based on the cantilever beam. Through this again you can understood how to go for the BM calculation for the cantilever beam. So one more figure I will draw here. So one cantilever beam is given. So one cantilever beam is there whose one end is fixed and another end is free. It is subjected to the some amount of UDL, and at the free end again one point load is applied. So one point load is also applied at the free end. So magnitude of that particular point load is given 2 kilonewton. Magnitude of this particular UDL is also given 1 kilonewton per meter. This is point A, this is point B, and this is point C. The distances are also given here. So AB distance is given as a 0.5 meter. And this BC distance is given 1.5 meter. So this is the cantilever beam. In the previous, whatever the previous problem we have solved, in that beam, cantilever beam is subjected to the all the three types of point loads. But here the cantilever beam whose one end is fixed, another end is free, and it is subjected to the two types of load. One is the UDL, which is applied on that particular span BC having length 1.5 meter, and one more point load is applied at the free end. The magnitude of that point load is 2 kilonewton, and we have to draw the Sfd and Bmd for this particular cantilever beam. So what is our first requirement? First of all, we have to go for the reaction calculation. First of all, we have to go for the reaction calculation. So we are starting for the reaction calculation, the first part. Summation of Fv, summation of vertical forces is equal to 0. How many forces are present? So here, as we know that the fixed support is there, that fixed support are having the two reactions. One is the vertical reaction, another is the horizontal reaction, and also that fixed support is subjected to the movement. But we need not require to take the horizontal reactions, only we have to take the vertical reaction. So here the reaction at point A, because the fixed support is there, that reaction will be considered as a RA. Okay, then it is moving in the upward direction, therefore we have taken it as a positive, minus this UDL. How much amount of UDL is there? 1 kilonewton per meter. It is applied on the span. How much amount of span is there? 1.5 meter. So here, if I will draw the loading diagram once again. So this is the reaction RA. Reaction RA. The UDL is converted into the point load. It will be indicated by the dotted lines. So what will be the magnitude? 1 into 1.5. So what is the magnitude? Please do the calculation. And this distance is given 0.5 meter, and this total distance is 1.5. This is point B, this is point C, and center point we can consider it as a capital P. So what is the magnitude of UDL when it is converted into the point load? 1 into 1.5 means you will get 1.5 kilo Newton. And the distance between point B and P, this is 0.75 and this is 0.75 meter. It will be applied at the center. Now summation of vertical forces means RA is the reaction which is moving in the upward direction. Another, this UDL converted into the point load, that is moving in the downward direction, therefore 1.5, and one more point load is there, it is moving in the downward direction, therefore 2 is equal to 0. And directly you will get the reaction RA is equal to 2.5 kilo Newton. Sorry, 3.5 kilonewton. So this is the reaction RA we have calculated. Now here there is only one support is there, so directly you will get the reaction value. In simply supported, in overhanging beams, there are two supports are there, maybe RA and RB. So we have to calculate the two reactions, but here only one support is there, therefore directly you will get the answer. So need not required to take the summation of MA is equal to 0, or summation of MC is equal to 0, or summation of MB is equal to 0. This step need not required to take in case of a cantilever beam. By using this particular single step only, that is summation of F is equal to 0, you got the answer. Now directly I will start with the SF calculation. SF calculation. As for the cantilever beam, again we have to start the SF calculation from the left side of the beam. So left side point means point A is there. So start SF at A, as there is a reaction, therefore without load, SF at A without load is equal to 0 kilonewton. Then next, SF at A with load, reaction we have calculated with load is equal to reaction RA, that is 3.5 kilonewton. Then SF at B, how many forces are present to the left side of the point B?
One.
Only one force, that is reaction RA. So we can take that force as it is, that is 3.5 kilo Newton. Then after point B, don't take the SF calculation at point P. This point P we have used just for our indication purpose, that is UDL is converted into the point load. So after the point B, directly you have to take the shear force, SF at the point C. But at point C, again the point load is there, so we have to take the two conditions, that is SF at C without load. Tell me how many forces are present to the left side?
Two.
Two forces are present. One is the reaction RA, which is moving in the upward direction, and that UDL we have converted into the point load, and its magnitude is 1.5 kilonewton. It is also present to the left side. Therefore, 3.5, it is positive, minus 1.5 or is equal to SF at point C, you will get, that is 2 kilonewton. And last, SF at C with load with load, that is without load already we have calculated 2. With load means by considering the point load at point C, 2 minus 2 is equal to 0 kilonewton. So again here the starting point and the end points are 0. That means your middle calculation is 100% correct. And now by using this particular calculation, we have to draw the shear force diagram. So how to draw the shear force diagram? So this is point A, point B, and point C. So shear force at point A without load, it is equal to 0, no problem. Shear force at point A without load plus 3.5 means positive value is there. So this is the 3.5. Then SF at B, again 3.5, that means constant line is there. This is 3.5 load. And SF at C without load, how much? 2. This is 2 kilonewton, and SF at point C with load is equal to 0. So this is the vertical line. Then the point between A and B, it will be drawn by the horizontal line. Then point B and C, it will be joined by the inclined line, because in between portion B and C your UDL is present, so automatically you will get the inclined line. And this particular figure, it represents your shear force diagram. Means the shear force diagram will be present in the positive region only, that is in the upper side of this particular horizontal line. That is the point B and C, it will be joined by the inclined line, because in case of a shear force diagram, if I have to represent the UDL, in case of a shear force diagram, if I have to represent the UDL, it can be represented by the inclined line. Therefore, from A to B, perfectly horizontal line is there, because there is no any force in between A and B, but in between B and C, there is a UDL is there. So from 3.5 and up to the 2 kilonewton, automatically you will get the inclined line. So this is SFD. This is the shear force diagram. Now we have to go for the BM calculation. So for the BM calculation, we have to start from the right side of that particular beam. So third, BM calculation. As we are starting from the right side, the clockwise movement we have to take negative, and anti-clockwise movement we have to take positive. So start from the right side. The bending moment at point C. What is the bending moment at point C?
0.
Bending moment at point C is equal to 0. So BM at C is equal to 0 kilonewton meter. Then bending moment at point B, how many forces are present to the right side? Bending moment at B, how many forces are present?
2.
2 forces are present. Which are those? One is the point load of the 2 kilonewton, and distance between point B and C, it is equal to 1.5 meter, and it is rotating clockwise. Therefore, you have to take minus 2 into 1.5, and one more point is present, that is that UDL we have converted into the point load, and its magnitude is 1.5 meter, and the distance between that point B and P is equal to 0.75 meter. Therefore, both the movements are rotates in the clockwise direction. Therefore, we have to take it as a negative, because as we are starting it from the right side. So here BM at B is equal to minus 2 into 1.5. This is the 1 point load. Another UDL converted into the couple, its magnitude is 1.5 into 0.75 is equal to. So what is the value? What is the bending moment at point B? Yes, minus
4.112.
minus 4.125 kilonewton meter. And then last point is remaining, that is SF at A. Tell me,
BMD
minus 2 into multiplying distance. Minus 2 into multiplying distance, you can see the figure.
2.
Minus 2 into distance between A and C is 0.5 meter plus 1.5 meters, means total 2.5 meter. And this UDL converted into the point load, it is also present to the right side. Its magnitude is 1.5. But what is the multiplying distance? 0.5 plus 0.75. How much?
1.25.
1.25. So like that we have to take. Only two loads are present, but only multiplying distances are to be changed. So minus 2 into 2 and one more 1.5 meter into 1.25 is equal to, yes, what is the bending moment at point?
Minus
5.875.
5.87.
Minus 5 point,
Minus 6.7.
minus 6,
Minus 5.87.
minus 5.875
kilonewton.
kilonewton meter. So at point C it is equal to 0. At point B minus 4 point. Why magnitude we will get the minus? Because all the movements are clockwise, and clockwise movement we have to represent by the negative sign. Therefore minus 4.125 and another minus 5.875. And by using this, if I will draw the bending moment diagram, so you will get the bending moment diagram like in the negative region only. So point A is present, point B is present, point C is present. At point C, it is equal to 0. At point C, you will get the magnitude minus 4.125, and another last point is there, minus 5.875. All the answers are negative. Now please tell me, in between portion B and C, whether it is joined by the inclined line or curve?
curve.
Inclined line.
Because in portion B and C there is a UDL is there. Therefore in case of a bending moment diagram, that 2 points can be joined by the parabolic curve. So this will be your parabolic curve. And what about AB?
Inclined line.
Inclined line.
It is inclined line, because in portion A and B there is no any load is present, but automatically that two points can be joined by the inclined line only. So this is the inclined line, and this is the negative region, and your bending moment diagram will be present in the negative region only. That's why yesterday also I have told, in case of a cantilever beam, whatever, in case of a cantilever beam, whatever the shear force diagram you will get, for the 90 to 95% problems are there in which the Sfd can be obtained in case of a positive region only, and your bending moment diagram can be obtained in the negative region only. Otherwise there are some 5 to 10% problems are there in which if we are changing the magnitude of load maybe in upward direction, or if any cantilever beam it is subjected to the couple, at that time there are chances to convert your Sfd from positive to negative, or your Bmd from the positive to negative. But maximum times you will get Sfd in the positive region only, and you will get Bmd in case of a negative region only. So this is about one more problem related to the cantilever beam. Now one more problem we will take. If that cantilever beam is subjected to the couple, if that particular cantilever beam, if it is subjected to the couple, then how to go for the Sfd and Bmd for that particular beam. So here I will give the loading diagram. You just go for the reaction calculation first, and then we'll go for the further calculation. So the cantilever beam, one end is fixed and it is subjected to one UDL from this particular fixed point. The UDL, this is point A, this is point B. The UDL is having magnitude 0.5 kilonewton per meter. Then it is subjected to one point load at point C. The magnitude of the point load is 2 kilonewton, and whatever the last point is there, D point, at that particular D point, it is subjected to one couple. It is subjected to one couple which is rotated in anti-clockwise direction, 3 kilonewton meter. The distances are also given. So AB distance is given 2 meter. BC distance 0.5 meter and the CD distance 1 meter. So this is the cantilever beam whose one end is fixed once again. From point A up to the point B, that is 2 meter span is there, and it is subjected to UDL of 0.5 kilonewton per meter. Then after point B, C point is there, subjected to the point load of the 2 kilonewton, and at the end point, whatever the free end of the beam is there, that free end of the beam is subjected to the couple, that is at point D. The couple is applied. It is rotating in anti-clockwise direction. According to the direction, it is rotating anti-clockwise direction. Its magnitude is 3 kilonewton meter. Already couple will be given in the form of kilonewton meter, so need not require to multiply by distance. Now first of all, go for the reaction calculation. First of all, we have to draw the loading diagram once again because UDL is given. If I will convert that particular UDL into the point load, so at point A, there will be the reaction RA. This is point A, this is point B, this is point C, and this is point D. At D point, couple is there, 3 kilonewton meter. At point C, point load is there, 2 kilonewton. If I will convert that particular UDL into the point load, it will be represented as a point P, and its magnitude is 0.5 into 2. 0.5 into 2 means you will get 0.5. Sorry, it will be acts as a center. That means 1 meter here, 1 meter here. This is 0.5 meter, and this is 1 meter. Okay, so this is the loading diagram. What I have done, UDL I have converted into the point load. Its magnitude is 0.5 into 2 because UDL is spread on only 2 meter length. Its magnitude is 0.5. So W into L means 0.5 into 2 means you will get the UDL converted into the point load as a 1 kilonewton. Then second point load 2 kilonewton as it is, couple is present as it is. Now we have to go for the reaction calculation. Only one reaction is there, that is summation of Fv is equal to 0. Ra, it is moving in upward, therefore positive, minus UDL converted into the point load 1. Another point load is given 2 is equal to 0. Don't take the effect of couple in reaction calculation because if you go through the unit of the couple, it is kilonewton meter. But summation of vertical forces, what is the unit of the forces? Only kilonewton or newton. So we have to take only forces. Don't take the couple. Therefore, you will get the reaction Ra is equal to 3 kilonewton. Okay. So this is the reaction calculation. There is only one reaction in case of a cantilever beam. So need not require to take summation of EMA is equal to 0, summation of EMB is equal to 0, summation of EMD is equal to 0. Directly in one step only, you will get the reaction. Now start the SF calculation. SF calculation. SF calculation. Start from the left side, because for the SF calculation, no problem. We can start from the left side. So SF at A, at point A, your point load or reaction is there. Therefore, we have to take without load. So without load means it is 0 kilonewton. Then SF at A with load, reaction we have calculated 3 kilonewton. Then SF at B, there is no any point load, there is no any reaction, therefore only single time SF at B. How many forces are present to the left side of the B?
2.
Two forces are present. One is the reaction and another is UDL. UDL जर आपण पॉइंट लोड मध्ये कन्वर्ट केलेलं आहे, त्याची मॅग्निट्यूड आपल्याला 1 किलोमीटर मिळाले, ती पण कुठं आहे, ह्या पॉइंट बी च्या लेफ्ट साइडलाच आहे. त्यामुळे RA 3, UDL converted into the point load 1 moving in the downward direction, therefore -1, which is equal to 2 kilonewton. Then SF at C, at point C, point load is there, therefore without load, again 2 kilonewton. SF at C with load means 2 minus 2 is equal to 0 kilonewton. SF at D, SF at D, how many forces are present to the left side of the point D? S, how many forces are present to the left side of the point D?
3.
Three forces are present. One is reaction, another UDL converted into the point load, and another is the 1 point load. So starting from the reaction, it is moving upward, therefore 3 positive. UDL converted into the point load, its magnitude is 1, moving downward, therefore -1. One more point load is there, moving in downward direction, -2. Again, SF at D is equal to 0 kilonewton. So this is about the SF calculation for this particular cantilever beam. Now here, if I will draw the SF diagram, so perfectly horizontal line first. This is point A, point B, C, and D. So at point A without load, 0, no problem. At point A with load, plus 3 kilonewton. So this is 3 kilonewton point. Then SF at point B, 2 kilonewton. So here, this is 2 kilonewton. SF at point C without load, again 2 kilonewton. So again, this is 2 kilonewton. SF at C with load, 0. SF at D with load, 0. That means in portion C and D, there is no any SFD. So how to draw the portion A to B, inclined line or the parabolic curve? Inclined line. So automatically
Inclined line.
inclined line. The portion B and C, both values are same, therefore this is 2 kilonewton, and C, it is equal to 0. This is the positive, and this will be your SFD. So if you see, in portion A and B, the UDL is there, therefore it is inclined line. In portion B and C, there is no any force, therefore horizontal line. After point C and up to the point D, there is no any force is present. बघा, point C पासून point D पर्यंत एकही force नाही. फ्रेंडला कपल आहे, पण SF calculation मध्ये don't take the effect of couple because it is given in kilonewton meter. Therefore from C to D, as there is no any force, therefore your shear force diagram is also not there in case of a portion C and D. Why? Because No any force is present in portion C and D. So this is about SFD. Now we'll go for the BM calculation. So third, BM calculation. We have to start it from the right side. So clockwise movement, once again, negative, anti-clockwise movement, positive. So start from the first point, the point of that particular figure. If you go through this particular figure, BM at D is equal to 0 kilonewton meter, because at the right side of the point D, not a single force is present. Then BM at C. Tell me, how many forces are present to the left side of the point C?
One couple.
The force is not present, but one couple is there. You can see in the figure, the force is not present at the right side, but one couple is present. What is the direction of the couple, clockwise or anti-clockwise?
Anti-clockwise.
Then we have to take it positive or negative?
Positive.
Positive.
We have to take it as a positive. Positive couple and positive moment. We have to take, anti-clockwise couple or anti-clockwise movement. We have to take it as a positive, because we are starting from the right side. The magnitude of couple as it is 3 kilonewton meter. Don't multiply by the distance, because already it is given in kilonewton meter. Then BM at B. Tell me how many forces are present to the left side of the point B?
Two.
Two forces are present. Out of that, one is the point load of 2 kilonewton and another is the couple. But if you see, the couple is rotating in anti-clockwise direction, therefore we have to take it as a positive. But whatever the 2 kilonewton force is there, which is acting in the downward direction, if I will rotate that particular point load, it will be rotating clockwise direction, and distance between point B and C is equal to 0.5 meter. So here, starting from the first, that is 3 kilonewton meter as it is, minus 2 into 0.5. Yes, what is the answer? 2 kilonewton.
2.
And last, BM at A. Now please tell me how many forces are present?
3.
3.
3 forces.
3 forces. Out of that 3, 2 point loads. One is couple, another is 2 kilonewton load, and one more load is total UDL converted into the point load. Its magnitude is 1 kilonewton. Now 3 kilonewton meter we have to take as it is as a positive. The distance between point A and B, 2 into 2.5, and another distance is, that is UDL converted into the point load, that is 1 kilonewton into 1 kilonewton, because distance between A and C, it is 2.5 meter, and distance between A and P, it is 1 meter. So here, if I will take 3 kilonewton as it is, minus point load 2 into 2.5 minus UDL converted into the point load is 1, and their multiplying distance is 1, is equal to, what is the answer?
Minus 3.
Minus 3 kilonewton. Okay, so this is the moment at that particular point. Now here, the bending moment diagram I will draw separately here. Okay, so this is point A, this is point B, this is point C, and this is point D. Starting from point D, it is 0. Okay, the bending moment at point C, how much? 3 kilonewton meter. So it is positive value. So here I have to represent that particular value as a positive. sorry, here we forgot one thing, that is bending moment at D. Couple is present. We have to take the effect of couple 2 times. We have to take the effect of couple 2 times. What is that condition? Bending moment at point D. For the couple, we have to take the 2 conditions. Which are these 2 conditions?
With couple, without couple.
Yes, with couple and without couple. जसं आपण एसएफ कॅल्क्युलेशन मध्ये एखाद्या पॉइंट लोडला किंवा एखाद्या रिएक्शनला विथ लोड अँड विदाउट लोड अशी कंडिशन घेतो, तसं बेंडिंग मोमेंट कॅल्क्युलेशन मध्ये जर कपल अप्लाय झाला असेल तर त्या पॉइंटला विदाउट कपल अँड विथ कपल, दॅट 2 conditions also we have to consider. Without couple is equal to 0, no problem. But what is the value for the with couple? 3 kilonewton meter. So here one step we forgot to write, that is this is the bending moment at D without couple. Without couple 0 kilonewton meter, no problem. But next, Bm at D with couple. What is the value for the with couple? What is the value for the with couple?
3.
3. It is rotated in anti-clockwise direction, and for the anti-clockwise we have taken positive sign, therefore 3 kilonewton meter. Okay, now we'll go for the BM diagram. Now bending moment at point D without couple 0, and with couple bending moment at D we have taken 2 times. One is without couple 0 and another is with couple, means 3 kilonewton meter. So this is 3 kilonewton meter. Then bending moment at point C, again 3 kilonewton meter. So again same point, horizontal line, 3 kilonewton meter. Then bending moment at point B, it is 2 kilonewton meter. So here this is 2 kilonewton meter. And bending moment at point A, negative, directly we have to go for the negative region. So at point A means 3 kilonewton meter, and we have to join all the points. So here from this particular D there will be the vertical line, then this will be the horizontal line, then this is inclined line. Now please tell me, in portion A and B the UDL is present. How to draw the point B to A?
Parabolic curve.
Parabolic curve here, and your bending moment diagram, it changes the sign from positive to negative. पॉझिटिव्ह व्हॅल्यू आहे 2 kilonewton मीटर, निगेटिव्ह व्हॅल्यू आपली खाली किती आले आहे -3. जर हे 2 पॉइंट जर जॉईन करायचे असतील तर आपल्याला कुठला कर्व लागणार आहे? पॅराबोलिक कर्व. सो दिस विल बी युअर and here you will get in between portion A and B you will get one more point Q. So this is positive region and this is the negative region. This is positive and the negative, and in between portion AB you will get the Q point. This point Q is called as a what? That particular point? Point of contraflexure. Please keep in mind. Point of contraflexure. What is the definition of point of contraflexure? It is the point at which bending moment diagram changes its sign from positive to negative or from negative to positive. Here in this particular diagram, the sign convention is changed from positive to negative. Therefore, this point Q is called as a point of contraflexure, as well as it is the point at which bending moment is 0. Therefore, you can see this horizontal line represents the 0 point or 0 line, and this Q point is also present on the 0 line. Therefore, this particular point Q is called as a point of contraflexure where bending moment is equal to 0. So I have told some of the problems are there in which, in case of a cantilever beam, then also you will get the such types of the point of contraflexure or the point of contra shear. But as compared to the simply supported and the cantilever beam, there are simply supported or the overhanging beam, there are very less problems are there in which you will get such types of the point of contraflexure or the point of contra shear. Otherwise, there are 90 to 95% problems are there in which your shear force diagram will be in only positive region and your bending moment diagram will be in the negative region. So that's why purposefully I have taken this particular problem, that is how your BMD will be changes the sign from positive to negative, means you will get the point of contraflexure. So this is about one problem based on the cantilever beam. Have you understood this particular problem, cantilever beam?
Yes, sir.
Yes, sir.
Okay, so Sfd and Bmd calculation for the cantilever beam, it is very simple. In very less chances that is we have to go for the x distance calculation. But if you look at to the simply supported beam and the overhanging beam, maximum times you will get the point of contra shear. Therefore, maximum times we have to calculate the x distance. If you have calculated the x distance, means we have to go for the calculation of maximum bending moment. But in case of a cantilever beam, very less chances are there where you will get the point of contra shear in case of a Sfd, because your Sfd is not changes the sign from positive to negative or negative to positive for the cantilever beam only. Therefore, need not require to calculate the x distance, need not require to calculate the maximum bending moment, because your Sfd will be present in positive region only and your BMD will be present in the negative region only. Okay, so these are the some sample problems for the cantilever beam in which we have solved basically three types of problems. The first problem we have solved related to the cantilever beam is subjected to the only point loads. So whatever the first problem we have solved, in that the cantilever beam is subjected to the 3-point loads. Today we have solved the second problem in which the beam is subjected to the UDL as well as 1-point load. And third problem whatever we have discussed or whatever solved just now, in which the beam is subjected to one UDL, 1-point load and one couple which is applied at the free end. In that, SF calculation will be same like simply supported and the overhanging beam, that is starting from the left side, and you will get the reaction value in the single step only. But whatever the BM calculations we have to do, we have to start it from the right side only. Therefore, your sign conventions will be changed. Clockwise couple, clockwise movement we have taken negative, anti-clockwise movement, anti-clockwise couple we have taken as a positive. In case of a SF calculation, whenever the point loads or the reactions are there, we are taking two conditions: without load and with load. Effect of couple, it will not be considered in the SF calculation. And in case of a BM calculation, whenever we are taking the bending moment at the couple point, we have to take the two conditions, that is bending moment at that point without couple means 0, and bending moment at that point with couple means with considering the couple, we have to take the magnitude of couple. So just now we have solved that particular problem. Without couple is 0, with couple 3 kilonewton meter. Why positive 3? Because that couple is rotating in the anti-clockwise direction, and anti-clockwise we have taken it as a positive. And this is the problem based on the cantilever beam. Okay, have you understood this particular all the problems whatever we have solved based on the cantilever beam? Yes, have you understood? Anybody is having any problem related to this cantilever beam? You can ask your questions if you are not understood any points.
No problem, sir.
Okay. So what about others? Everyone has understood this particular type, Sfd and Bmd for the cantilever beam? Okay, so the chapter is very simple. Only you have to remind the sign conventions. If you remind the sign conventions very easily, you can solve any type of problem anytime, because here need not require to remind any formula, need not require to go for any types of derivation. Only sign conventions are important. So if you remind that particular sign conventions, you can solve any type of problems based on the SFD and BMD for the simply supported beam, overhanging beam, and the cantilever beam. Okay, so with this today, here we have finished our chapter number 4 based on the SFD and the BMD for the simply supported beam, overhanging beam, and the cantilever beam.